Hi everyone, welcome to this month's Rancher Lab Meetup. Looks like we're going to have a great turnout today with an enormous crowd, so thanks everyone for joining us. Really excited about the topic today. It should be a lot of fun. We're going to be trying to touch on a whole bunch of topics, so sometimes that can be a bit dangerous and we may go long, so hopefully we'll be moving quickly and it shouldn't take us too long to get everything going. The meetup today is going to be with a pretty good group of people. We're going to have a number of different speakers. I'm Shannon Williams. I'm one of the co-founders here at Rancher Labs, and I run all of our marketing and field options. I'm joined by my co-host every month for these meetups, Darren Shepard, who's our chief architect and also one of the founders here at Rancher. Darren, you want to say hi?
Hi. Welcome, everyone.
All right. So Darren and I are going to be talking quite a bit at the beginning, but we've got two people joining us today. One is Bill Maxwell, who has spoken on a number of these sessions in the past. Bill leads our DevOps team here at Rancher. Bill, you want to say hi?
Hey, everyone. Good to be here.
And our other guest is Brandon Papworth, who's the director of web at Dom & Tom, a design company based in the Chicago area. And Brandon's going to be walking through how they're using Rancher, and he's got some really interesting things to show. So, Brandon, you want to say hello as well?
Hey, everyone.
Okay. Well, everyone sounds like we're coming through well, and you can hear us. So, really quickly, just to kind of, for anyone who hasn't attended one of our meetups in the past, this really is designed to be a meetup and not a webinar. We host these every month. We get a lot of people who attend more than one of these that come back over and over to get the latest and learn more about what's going on around containers and different topics that we cover every month. And we love having all of you come back. But because it's a meetup, we have sort of a set of rules that we kind of start with every time. The most important one is there's no sort of fixed time for this event. We go as long as we need to cover the topic. And because of that, we record everything. It's all recorded. It will all be posted online. You'll be able to watch a replay of it, by tomorrow or at the latest early next week. And we share the slides. We make everything available. So it's very open, just like everything. And the other thing that's very different is this is really designed to be a question and discussion session. So we're going to talk. We're going to show things, but we get literally hundreds of questions from the audience every month, and we do our best to answer all of them in the flow as it makes sense. So if something's confusing and we're not making sense, or the demo just isn't clear to you what we're trying to communicate, use the question tab in GoToWebinar here, and just type in your questions. We'll try to respond in a timely fashion. Sometimes, if your question is on something we're going to cover in a few minutes, I may hold off on it. Or if it's not really relevant to what we're going through right now, but maybe more of an overall question about something that you're curious about, Docker or Rancher, one of the tools we're talking about, I may push it to the end. But there aren't any bad questions. We'll answer them either in text or answer them over the phone. And don't hesitate. We also won't leave before we've answered all your questions. So at least Darren and I will be on the phone, as long as it takes. I think our longest now is 2.5 hours or so of answering questions and discussing things. But we'll try to move quickly through the content so we don't take up your whole day, and then save as many of the questions as we can to the end. The other thing that makes this a lot different than sort of maybe your typical webinar is everything is live. We demo everything on the fly. We don't record videos. We don't use screenshots. When we talk, we show, and we show you how to do things. And because of that, sometimes things break, so please be patient. Even our guests demo, so be nice. Brandon's demoing some of the stuff they're doing. Bill is going to be demoing some cool stuff we're doing with Vault. So just be patient and expect that everything should come together, but you never know. Because it's a meetup, we really love kind of everyone connecting, and that's hard with an online meetup like this. But we have a great group of people who communicate on Twitter. We have a Twitter hashtag Rancher Meetup that people are constantly introducing themselves, sharing what they're doing, getting to know one another, meeting in the community. One of the, since our first meetup, people started posting pictures of what they do while they watch the meetup. We love it. We love seeing you all. So please don't hesitate to throw up a picture, and we'll add it to our wall of shares. So, if you're asking questions on the meetup, on Twitter, obviously it's a little harder for us to get to those, but we'll typically come back around and answer them when the whole thing is done. Okay, so today's agenda, we've got a lot to cover. We're going to it's a little bit of a different, I think a really fun topic today, because we're not hitting one big topic. We're actually going to be showing you a number of different tools and capabilities that are available, to work with your, containerized environments. And we're hitting really 4 key tools in this. I'm going to start us off just talking a little bit about kind of the different tools that are out there and how the catalog and the set of the work that people are doing in the community is leveraging a lot of the different hooks that are available in Rancher, in Docker, to build new tools. And because of this, we're seeing just an amazing set of tools that people are sharing and showing how you can do really cool things. And that was really the goal today. We wanted to kind of share some of these great things that people have built in the community, some that we've built. So we'll go through that. Darren's going to be demoing as, kind of as I go. So we'll talk about some of these tools like, Prometheus for monitoring and dashboarding, Janitor for cleaning up your environments, Cowbell, which is just sort of the cool webhook tool that we've built here at Rancher, and we'll demo these as we go along, and as always, ask your questions. Bill is then going to take us down a little bit deeper into Vault. If you're not familiar with Vault, it's a really cool secret management platform from HashiCorp, and we're just rolling out a really nice integration with Vault that you'll see over the next couple of weeks. And so he's going to demo that and talk a little bit more. It's a little more complex because there's a lot of secret components and security to it, so he'll go through that. Then Brandon will come in and he'll talk a little bit about how they're using Rancher Dom Tom and some of the engagements they're working on with clients to do really cool things that containers are enabling. So I think it's going to be a great session. At the end of that, Brandon's going to jump in and give a quick demo of what he's been doing and working on, and we'll end up with obviously all of your questions and also just a quick update on some of the latest releases of Rancher and what's going on in the community that Darren will walk through. Okay, so really quickly, for those of you who aren't familiar with Rancher Labs, or maybe this is your first time, Rancher Labs is an open source software company. We build software and make it available to anyone who wants to use it. Our 2 primary projects are Rancher and Rancher OS. Rancher is a container management platform that allows you to deploy, containerized environments using, Kubernetes, Swarm, and really all sorts of different approaches to managing those applications when you're running them. So I'll talk about that in just a second. Rancher OS is a tiny little operating system that's built to run Docker, and it's a distribution of Linux that really removes everything but the absolute minimum to harden the environment and to reduce the number of times people need to upgrade and manage their setup. So let's just really quickly, I'll kind of walk you through the idea behind Rancher so you understand. We're going to be demoing a lot of things today in Rancher, but Rancher's effectively called a container service by most of our users, and that means that what it is a piece of software that effectively sits above your infrastructure layer. So regardless of where you get your hosts from, whether they're coming from the cloud, they're bare metal servers or laptops or VMs, Rancher basically consumes Linux hosts and allows you to deliver them as environments to users, and because of that, it makes it very easy to deploy your Dockerized applications on any infrastructure with a very consistent experience. And to do this, there's a number of services that we fundamentally have to deliver, and this is, Rancher just came out of beta last month, but for the last 18 months, we've been working with users on how to actually build out a container service and manage applications, and it really is a combination of a ton of different things. I mean, when we first started working with people, they were mostly building this themselves, using a lot of different open source tools to put together their container service, and included everything from, implementing their container networking to figuring out how to manage the Docker engines to connecting to registries and doing, multi-server networking environments, all the way up through deploying schedulers, configuring monitoring. And what Rancher really introduced for the first time was, a fully open source management platform that could consume all these different tools and allow users to very quickly start deploying containerized environments. And so if you think of Rancher, the best way to think of it is basically a management platform that consumes all of these hosts, allows you to group them into environments, define who can access those environments, but then within those environments, all of the kind of critical infrastructure services like networking and storage are automatically taken care of and sorted. And then for the environment, you can choose whether you want that environment to use Kubernetes, Docker Swarm, Rancher's own cattle orchestration, and and there'll probably be more coming in the future. So you can deploy different orchestration tools, connect those obviously through the API or the CLIs to your existing DevOps tools and pipelines, to really make it simple to push out applications, upgrade them, scale them, add capacity, and eventually deliver a full catalog of applications. So that's really quick overview of what Rancher is. It's open source software. You can find it on GitHub and download and set it up very easily. So today our focus is not as much on Rancher or any getting started type of tips, but really more about for people who are actually already using containers and are interested in looking at how they can expand their capabilities and leveraging some of the cool tools that are showing up in the community and taking some best practices for managing your environments, from the actual container infrastructure to the how you work with those containers. We're going to cover a lot of different things. And what's great about the container world is it is a very open source world. Not only is Docker itself open source, Rancher's open source, but almost all the tools we're going to talk about today, in fact, all the tools we're talking about today are open source tools. So it's very easy to come in, grab something, try it out, get comfortable with it, and you can get a ton of value from these different tools. The catalog in Rancher is if you haven't used it already, it's really a great place to start, because what you see in the catalog is users and vendors developing not just images. So the catalog kind of goes beyond a registry where you might say, here is an image of a specific thing. A catalog is a combination of an image or multiple images, but also some some links, some scheduling policies, maybe some HA configurations. So it allows you to deploy something a little more complex, a full Jenkins cluster, or an entire Elasticsearch environment, or really a number of nodes on every host. So it combines the individual images and often images from from public Docker registry, official images from vendors, with some scheduling policies, some placement rules, and some configuration choices that allow you to pick how you want to do this. So we're going to go through this in the demo, but there is so much in the catalog that deals with things like deploying a registry or setting up a code repo like GitLab, or implementing one of any of many different CI/CD tools like GoCD or Jenkins or Drone, to deploying all sorts of great logging tools. We're going to look at Prometheus today, but there's really great tools from Sysdig, from Datadog, from Weave that are in the catalog. To setting up key value stores, you'll see Consul, etcd, Zookeeper, all sort of defined, to deploying different storage services like Convoy and a whole bunch more that are coming, and different types of data services. I think we see quite a bit of deployments that are around Galera and MariaDB and Mongo, and different types of clustered data services. So lots of different things to find in the catalog, and this whole thing is open source and community driven. It's you can contribute anything to the catalog. If you attended our recent Meetup, we talked about how to build catalog items. If you didn't, it's recorded, and it's a great place to start if you've got things you'd love to contribute. And it can be a great way to promote projects. I think that I'm always amazed. We've seen now I think the number is well over 50,000 plus deployments of these of some of these applications. So we're seeing lots and lots of people pulling down and trying all sorts of different tools that are available in the catalog to get access to them. So the interesting thing about some of the tools is that not only are they great tools, but many of them are being integrated into Rancher to do interesting things. And that the way that happens is that when you look at some of the work we're going to talk about today, it goes beyond just deploying an application, but actually designing kind of an extension to Rancher that runs as a catalog item and runs as a container or a set of containers. So we're going to go through a few today, and really it's really become a driving way that we think of deploying tools. And the first one we did like this was for Amazon's Route 53, where we looked and said, let's do an integration that automatically configures Route 53 whenever new hosts are added to a service, or maybe a load balancer gets distributed to a new host. And so we didn't want to do a tight integration. We want to do an integration that we would write for Route 53 with Amazon, and then anyone else that had a DNS service could come in and write their own. And it worked really well. And I think it set up the template for how to build tools, not as deep plugins, but almost as microservices that could be added to Rancher, launched from the catalog, run within an environment, and and scale as the environment grows. So to do that, a lot of these tools are leveraging not just the templates and the sort of catalog frameworks for for Kubernetes or for Cattle or for Swarm, but they're also talking to the APIs of Rancher itself, maybe to pull data, or they're often talking to the metadata services within Rancher to get information about other services or themselves, so they can configure and set up the environment. And then the best of these are getting distributed through the catalog, and now we're seeing a lot that are getting quite configurable, where you have choice about how to deploy them, where you want them, which hosts you want them to run on, how you want them to integrate with maybe an external service. So something like the Datadog plugin and the Assisted Cloud plugins are good examples where they ask you to provide your credentials to the different services you're going to connect to out in the SaaS world, and then they set up and configure all of the integration there. So configurability and schedulability are kind of big pluses for anyone that's building these things and wants to make them really useful for users. So help people want to define how they want to schedule and makes things go a lot further. And that's something that all of these that we're going to talk about today have sort of thought through really well, I think. So the four topics we're going to touch on today are kind of cover a pretty broad set of capabilities. The first one we're going to jump into, and Darren's going to demo, is a tool called Cowbell that Bill initially developed, and the team here at Rancher has been working on for on and off with some users over the last couple of months. And Cowbell really is designed to create webhooks that you can call to externally to make Rancher do things. Then we're going to jump in and talk about Prometheus, an open source monitoring tool that was built by the SoundCloud guys to build and how one team has taken that and built a really cool dashboarding capability that's actually feeding a lot of our work on dashboards into Rancher that eventually will become part of the product. So talk a little bit about that. Then we're going to talk about Janitor, which is a really simple concept, but a very useful tool that actually cleans up a lot of orphaned images and volumes and things that are left on your server. And finally, we'll jump into Vault, which I think there's a ton of interest in, I know, in the community, and it's an amazingly cool secret management service. And Bill will go through and talk about how Vault works, but more importantly, how the integration has been set up. So to get us started, I want to talk about Cowbell and the work we've done here, and then I'm going to turn it over to Darren, and he's going to dive into a demonstration of this. But Cowbell is a service that you'll see in the catalog. I think if not today, in the next day or two, we're finally making it available. But what it is, it's a small microservice that you deploy in your environment, and it exposes webhooks for any system you want to be able to talk to your environment's APIs or CLIs to take actions. And those actions could be scaling up a service, scaling down a service, upgrading or redeploying a service. and often these are integrated with your CI/CD system. So we use these internally and in a number of our testing and deployment cycles. I think they'll be really useful for users. So the way you'll deploy Cowbell is you'll just deploy it within the environment from a catalog, and you can choose where you want it to run and how you want it to run. So I'm going to stop there and turn things over to Darren. Darren, are you all set?
Yeah. Can you hear me?
I can hear you just fine, and you should have control. Do you want to share your screen?
Yeah. All right.
Okay, I can see your screen. You're presenting.
Okay. So I'm going to demo Cowbell, and I just want to reiterate just some of the things that Shannon talked about already about what we're trying to kind of do in this meetup here is really show people how they can build these services and microservices to augment and enhance Rancher. Like Rancher, we've gotten just tons and tons of feature requests. And they're all a lot of really great ideas, and obviously we can't build them all ourselves. But the way that we've architected and designed Rancher has been from this idea that the core of the system, the core orchestration, should stay quite simple, and we really don't want to augment that much, add more code there. And the direction going forward is really to be building more things as these microservices that you deploy into your environment. And so Cowbell is a good example of how you can do that. As Shannon pointed out, external DNS, that component that we did, which integrated with Route 53, was really our first experiment with this architecture, and it worked out really well. And then going forward, I think the majority of features are going to be developed this way. But the great thing is if it's the core Rancher team developing it, or if it's the community developing it, it's done in the same way. Which I really think is great, because we've seen some excellent things come out of the community, like the Let's Encrypt integration, which has come, which basically is integrated into our load balancer to do Let's Encrypt SSL management. Okay, so let me actually just get into Cowbell now and actually show you how this works. So Cowbell, what we're going to do is we're going to deploy this by just adding in a custom catalog. And we've seen this, when you look at catalog today, we have, basically the, oops, let me clear that. We have, our community catalog, then we also have a catalog which is kind of certified by Rancher. But what we're seeing with users is that since a catalog is just a GitHub repo, people can just create their own catalogs really easily. And we're seeing within organizations or even out on the internet that people create these kind of, they bundle up their own little tools and put them into their own repo. And so kind of this pattern of building your own little catalog with all your little tools is becoming quite popular. So with Cowbell, what I'm going to do, this is right now this is on my personal GitHub account. It's I Build the Cloud Cowbell. We'll move it over to Rancher. Shortly publish this as kind of an official project. So that I'm just going to copy the GitHub URL here. So let me add in this Cowbell and URL. And once you add that, we should be able to go to the catalog. We can see Cowbell is already deployed, or already there in the catalog. So let me just click here and deploy this. And we're going to go through, and there's just basically two options. First is some random token, because basically what we're going to be doing is exposing a series of URLs, like special URLs that you can hit from the public internet, or whatever's accessible to your Rancher deployment, but in this situation is going to be the public internet. So you want to put something random that somebody else won't guess, and that's just a kind of a security mechanism. Since I'm demoing this, I'm going to just put something short because I'm going to be typing this. So I'm just going to put T. And then you need basically some public port. That's whatever port you want to expose this service on. Now before I deploy this, I want to go over this compose file a little bit. As you can see, this is our service here. It's just I Build the Cloud Cowbell, and as the token and the port we're going to expose. Now the important part here is actually these two labels. Now this was something we originally created. We created these labels kind of for internal use, but then just found them out, and they've ended up being extremely useful. Now what these two kind of magical labels here are doing is what happens is when we deploy this container, we actually create credentials and set credentials as environment variables on the container that's launched. So basically what happens is once this container is deployed, it has API keys that can act on behalf of the environment to do things. So before we had metadata. Metadata is just read-only, and you can see what's available within your environment. But by doing, basically adding these labels, we can now actually interact and augment and change the environment with a service. So this is kind of the secret to making this work, is by adding these labels. And when we do this, basically it's going to set 3 environment variables: cattle URL, cattle access key, and cattle secret key. Okay, so let me click launch. And so this is going to go and deploy Cowbell. Let's just give it a second to deploy here. Okay, so now that Cowbell is deployed, let me just click on the port here. So this is just kind of a little info page about the various operations that we can do with this. And so right now, Cowbell, I mean, it's very simple. Basically, we just do scale up, scale down. You can scale to a specific number. You can do an upgrade where you actually pass in a new Docker Compose or Rancher Compose file, or you can do a redeploy. So let me show how this kind of works. Let me just create a very simple service. So let me create a new stack. I'm just going to call this test. I'm going to add in a service called Hi, and it's going to be my very complex service that I developed here. I built the cloud Hi. Let me deploy that, and I'm going to put a load balancer in front of it. So as I scale this up, you can hit it on multiple instances of it. Call them LB. We're going to load balance to the Hi service. Okay, we just got to give the load balancer just a second to deploy here. Okay, it's coming up. So I should be able to click here on that. And so my very complicated service says Hi. So it's basically the Nginx container that just says Hi. Okay, so now that we've got this thing deployed here, let me go back to what I had on Cowbell. So we can use kind of this format of the URL to now start playing with this service. And the other thing is what we can do, all the URLs, they have a token, which I just set as T. You should really use something longer and more secure. But what you can do is you can say, put the token in there in jobs, and then this will kind of list what has been ran. And so we'll refer back to this to kind of see what's going on with our webhook receiver here. So let me pull up a console here. So, okay, curl. So what we're going to do, curl post. Let's just try scaling up a service. So this is the URL we're going to hit. Let me paste that there. Put in the token. We're going to say scale, and then you want to do stack and then service. So the stack that I created, switch the tab over, was called test, and the service is Hi, and I'm just going to scale it up. So when I hit that, so you can see, when I hit this URL, it starts scaling up the service. So if I go back to the jobs here, you can say, okay, here's this job, it's done, and there's the output. Basically, all this tool is doing is just running Rancher Compose. So this is just various incarnations of Rancher Compose. So you can see, so we scaled this up to 2 containers, or I can say, okay, well let's scale this up. We can scale it up again, or we can say scale to a specific number. I'm going to do 6. So if I go back to the jobs here, you can see both those are running because I ran those in parallel, but they should both eventually finish once this gets up to 6 containers. Oops, I'm looking at the load balancer service. There we go. So this is deploying Let's see, we're up to 3, and then I think because I did one scale up, so I went up to 3, and then I did 6, and so it'll go up to 6. So. Okay. So that's just kind of a basic, we can scale up, scale down. Now the more important, the more interesting one. Yeah.
Can I jump in with just a question or two that came in while we were talking? One of them was a question that, here, just give me one second, let me open this up, that Willis, I think it's Wills asked, and he was asking if it would be possible to put the Cowbell behind a load balancer and not expose the container port publicly. Are there ways to disable exposed ports from the template?
Yeah, that right now that's kind of a limitation, honestly, of the catalog. That's something we're kind of working on with the catalog. Right now, there's kind of there's two things in the catalog that kind of become tricky when people deploying things. One is exposed ports, and the second is scheduling, like where you actually put the service. So what we're working on right now with the catalog is making this more flexible, such that when you deploy here, where it asks for the port, you'll basically have the option of picking a port, saying you want a random port, or not expose a port at all. And so if you didn't expose a port, then you would be able to put a load balancer in front of it. So right now, we don't kind of have that capability in the catalog. But if this causes a major problem for you, you can see the catalog entry is very simple. You can very easily, fork this repo, change it, just drop the ports, add a load balancer. You can, just however you want.
Great, thanks, Darren. There was another question that Kanwar Batra asked, and he asked if it was possible to restrict users who can scale up services from the command line. Darren, does that make sense?
You can scale up. One, I'm trying to think, because the command line in terms of like Rancher Compose, I mean, we have like some basic level. I don't have authorization turned on here, but we have some basic levels of access control. You can do like a read-only user so that they can see things, but they can't scale up or scale down or deploy things. But right now, we don't have the fine RBAC. This is definitely a feature that we're working on, especially for a lot of our enterprise customers. Right now, in terms of the
question, there's one last question that came in on sort of the same topic.
I was just going to say that.
Oh, go ahead.
Sure. I was just going to say, in terms of this webhook thing, when you deploy like these webhooks, really like the security of this is really based around the uniqueness of this token, and who knows the token. Which basically, if anyone has access to the environment, they could actually, just basically go to Cowbell and click on it, find out, it'll end up just being in the environment variable. So it's not, that's not really kind of hidden from most users. Yeah.
So the other question was, could Cowbell be used by referencing an L7 location, such as cowbell.server.domain? Any ideas about that?
No, actually, we haven't actually thought of that. Like in terms of looking at, like you want to look at like the host name routing, kind of the host name routing rules. But that would definitely be interesting. Honestly, we would love to see PRs come in. Basically, the code's really quite simple in here for where is it? Sorry, yeah, it's Compose here. Basically just adding in pretty much a new way that we can scale the service or look up the service. Right now, it's just based on stack and service, but we could have a different criteria to look it up. So we'll push this. We'll push Cowbell out to Rancher. It'll be like into the official repo, and then I'm sure we'll get plenty of feature requests and issues. So.
Another question is, what's the main advantages between using Cowbell instead of just calling the Rancher API? That's what Tristan was asking.
Oh, well, so so that's kind of the next step of what I was going to show is basically, I mean, the reason why you want to do this is actually to integrate with systems that are publishing to a webhook. And so maybe that would be best demonstrated with, like when I do like the next part of the demo.
Okay. Why don't you go ahead. There's a couple more questions, but I'll hit them when you wrap up.
Okay. So so what I'm showing you here is basically scale up and scale down. But one of an interesting one that we have here is redeploy. And so basically what redeploy is going to do is it's the equivalent of doing a Rancher compose up, force upgrade, and pull, which is basically just redeploy the whole application and pull new images if you need to. So let me just run this once. I'll show you how this one works. Let me go back to my kind of test service here. So you can see when I launch redeploy test, so I can say if I want to just redeploy the whole stack or just an individual service. I'm just going to do this service. So we should start. Make sure that in fact is running. Yes, that is running. So the very first thing, the reason why you're not seeing anything going on in the UI quite yet is the very first thing it does is actually it pulls all the images. It pulls like a new version of it. So it takes a second for that to, yeah, so it's finished pulling. Now you can see it's doing the actual upgrade. And this is, when we do a redeploy, it's actually doing a rolling upgrade. So we're shutting down, the default batch size is 2, so we're shutting down 2 containers, then deploying 2 new containers. So you can see as we're upgrading this or redeploying this service, it should be still, I can refresh and it's still available there. Okay, so so now the kind of the more interesting thing of why you care about doing these webhooks with the URLs is the whole idea of this is that we can integrate, I can take this URL and integrate it into a system that's designed for webhooks. So I'm going to go to Docker Hub. So if I go to Docker Hub here, so I have that image that I created. I build the cloud, hi. Okay. So this is my image that is running that service that just echoes hi. So here in Docker Hub, you can see they have webhooks. So you can go and you can add a webhook. I'm just going to call this Cowbell. You can name it whatever you want. But basically, I can put this URL. So this is the URL that I've deployed. And so basically, invalid value. There we go. So basically what's going to happen is every single time I push a new image to this, it's going to end up calling my webhook. So I can demo that here. Let's go to my very complicated source here for this image. And I'm going to change this from hi to hello. So I can go and build, Docker build, I build, hi. Okay, so I built this new image, and I'm going to push it. Okay. Okay, so I push that. Now if I go up here and I click on view history, if everything worked right, you can see it called this webhook. If I go back to my Cowbell output, you can see something is running here. If I go back here, you can see, let me just refresh this one. Okay. You can see we're actually doing an upgrade right now in the process. If I, yeah, you can see I'm refreshing here, and you can see it's kind of flipping between hi and hello. That's because it's doing a rolling upgrade. And so slowly as this continues, to do the upgrade, all of these services will eventually become hello. Yeah, so pretty much as I'm refreshing now, it's always hello. So basically, this webhook receiver ends up being a very easy way to plug into your CI/CD systems, because there's a lot of systems like GitHub or Docker Hub or various things that will post to a webhook. And so this is a very easy way to integrate with that. And so you can see with kind of this very simple flow, this ends up being pretty powerful that I can basically, anytime an image is pushed it automatically calls the webhook, and then I do an operation like redeploy or upgrade, and then I have the new version of my application. So if I was to go and change this again to hello world and push it in my Rancher environment, the image would automatically be updated.
That's awesome, Darren.
Okay.
Really cool.
So that basically concludes my demo of Cowbell.
I was just going to say there's a bunch of questions that came in. Do you want me to run through a couple of these really quick? So one question that was asked was, how do you handle failures during deployment? Darren?
How do we handle failures? Yeah. So basically, the operations they do the equivalent of. So if the upgrade, I'm trying to think. So basically, if the upgrade failed for some reason, because this is fully automated, basically we just leave it in a failed upgrade state, and then the next time the webhook goes through, it'll try to upgrade again, and then hopefully the next upgrade will work. It's for basically to do a rollback, because like we do have rollback built into our upgrade mechanism. To do a rollback, we need to do that requires basically a manual operation. But I could see we could very easily add that into Cowbell to basically to do an automatic rollback if the upgrade didn't work. I wouldn't say this is something for CI/CD systems. I don't know, if I necessarily see a lot of people doing this directly into production of like deploying applications as their primary means of deploying. Maybe not. If you really have a well-ironed procedure that works. But for right now, it works really well for basically like deploying out into your test and integration environments.
Another question was, how does Cowbell work across different environments, or how does Cowbell work across environments? Alejandro Mesa asked.
Yeah, so basically everything right now in Rancher is really scoped to an environment, so it's per environment that you set this up. So, that's definitely something, we're looking at on how to do cross-environment stuff, but pretty much everything is kind of encapsulated at that level.
I think in most cases that's sort of the expected behavior too, is that, like secrets and things, you still want those to be quite specific to an environment. So, you wouldn't probably want the same token across different environments and things like that, because you might have different access privileges. So be able to revoke and change those as you go. Gilman Carlson asked, can you specify an image version on redeploy so it's not only latest?
Well, the whole idea of redeploy is basically to just deploy the exact same thing that you've done. So it's tailored for latest. If you want to do a specific image version, then I would say you probably want to do upgrade, and then upgrade you have to pass. So let me go back to where I had. Basically, if you pass upgrade, you have to give it a URL of where to find like the new Rancher Compose or Docker Compose file, and then that can have a new version. So what you could do is you could create you could post to a URL that it's like the URL you're posting to for the webhook has in it the URL that points to a Compose file from like your Git repository. So it's kind of like as you update that in Git, it then automatically updates and then pushes out. So you really need to use the upgrade procedure for that.
Awesome. Okay, so I think there's a few more questions, but I think we're going to probably keep moving here. We'll try and come back to these as we go, guys, or Darren can answer them in the chat if while Bill's demoing, hopefully. Darren, that was great. I'm just going to kind of claim back the speaker role here, and or the presenter role,
All right.
and going to jump through, and we'll jump now to the next topic, which is Prometheus. So Prometheus is is really a powerful tool for monitoring your environments. It effectively gives you the ability to deploy, an open source platform with fully integrated database to actually look at the performance of your containers and show all of that. The Prometheus itself was created by the team at SoundCloud. Really great team. We've been working with them a lot and think really highly of them. One of the catalog deployment though in Rancher is really interesting because it goes into a lot of the stuff Darren was talking about. It kind of jumps to not only deploying Prometheus but thinking about how Prometheus would work in a Rancher environment to get that Prometheus engine monitoring not just the containers and the host but actually the whole Rancher deployment as well. And it was created by a great group of guys at InfinityWorks in the UK NHS who shared it back with everyone. So really appreciate the work they've been doing to share it. And what we're going to show today is kind of how they built this, how it works, how to deploy your environment, these different components. The key piece though you can see here in just the screenshot is that in addition to deploying out Prometheus itself and the Grafana front end and the InfluxDB, there's these two components, one called Ranchi and one that's called the Rancher API integration that run on the individual containers as well. So great, Darren's gonna walk through this and show how to configure your dashboards, and we've been working with the Prometheus team and the teams that built this on how to incorporate this into some new dashboarding that'll be coming out in the next version of Rancher. So we'll hopefully you'll see the same capabilities just get baked more and more into the platform as we go. But really excited about this. I think it goes a long way to making it possible to manage not just the apps you're deploying, but also the the underlying infrastructure that you're running Rancher on. So I'm going to make Darren the presenter again, and he's going to dive into Prometheus. Darren, you should have the command.
All right. Okay, so for Prometheus here, so again, kind of following this theme. So someone added a service. When we do these demos, I actually purposely don't add auth because I don't mind like people hitting this and poking around or whatever. So anyways, for Prometheus, this is actually something that's already in the catalog. So it's developed by NHS and InfinityWorks, and they really did just a stellar job at this. And so, kind of following the theme of what we're talking about is just different ways to integrate with Rancher and augment it. And so we really wanted to show this Prometheus how they kind of plugged into Rancher in the different ways and leveraged what was already there to make a really cool Prometheus dashboards here. So I lost where it is. So Prometheus. So basically, if you just go here and add Prometheus, they have a good amount of documentation and explanation of how this all works. You can see, oops, most of this. Anyways, various URLs. They'll basically tell you how this all works, but I'll kind of go through this a little bit. So I already have this deployed, so I'm not going to actually deploy it right now because I wanted to have a little bit of historical data and whatnot so you can see it. But actually, this one there's no options or anything. You just click launch, and it's a pretty involved stack. It has quite a few things running here. So let me go and show you the stack now. Here. So they have basically InfluxDB, Grafana, Prometheus, this node exporter, Ranchi, and Rancher API integration. And so this here, I'll actually show you the the end result here, which is Grafana. The default is admin. Close that. So what they've done here is they have a series of default dashboards like already configured. So you can see here they created one which is the total running number of containers, how much memory they're using. So you can see I have 10 gigabytes available. I'm actually using 9 right now. You can see the various host stats which is going on. And then the Rancher server itself, like how Rancher server is behaving. And then finally they have, this is an interesting approach here, that they basically pulled out the stack health and put it into this separate dashboard. And the reason why they had originally done this is they wanted to just create a simple dashboard for kind of their ops team, such that they wouldn't actually have to go into the Rancher UI. They can just get a good high-level status, and they did this by building this dashboard here. So each one of these things is using kind of a different level of integration. So the container totals here is actually hitting the cAdvisor. So on each host, we actually deploy cAdvisor. It's running on in just the regular agent on each host. And so cAdvisor is kind of our default approach of, like, when you click and you get graphs. So if I just click on something like this, and our basic graphs that we have for CPU networking, we're just pulling this data from cAdvisor. And so Prometheus has an integration with cAdvisor, or actually it's kind of the opposite. Like, the cAdvisor will immediately can export to Prometheus. I think in this configuration they're actually, oh wait, no. So I think it's exporting the cAdvisor data. It's going to Prometheus to store it there. So they've used the, go back to the stack. Let me show you the stack. So basically, I believe it's this, the node exporter is actually the one that is grabbing this data and publishing it out. I hope I don't explain that one wrong. So for this Prometheus stack, basically they're integrating with the cAdvisor, which we already have deployed. And then the second thing that they're doing is this Rancher API integration, which is this little Node.js microservice that is actually, now if I go and I click, let me show you the stack here. Oops. Rancher API integration. Okay, so you can see here they're using the approach that I showed you before of basically for the Rancher API integration, they're getting API keys, and then they've written this little Node.js service to hit our API and then scrape out some data and then publish it into Grafana. Sorry, into Prometheus, which then displayed by Grafana. So here's an example of that, so that they're hitting the API and pulling this information. Now the last thing that they're doing here with this stack, and this is pretty neat, is Rancher actually by default, we publish out a lot of information. We use this for like our own performance tuning and whatnot, and we publish out a bunch of stats about what's going on inside of Rancher. And once you deploy this stack, you just need to set this graphite host variable. So I'll show you here. It's kind of a little bit of advanced setting, but there's actually good documentation that they put together here on how to set this up. If I go here, you just need to set this up of wherever, set up the graphite host to wherever that service got deployed, and that's how they're collecting all these stats here. So you can see like JVM heap usage, failed events. These are various if things are kind of going bad. The average ping time of when we're trying to hit a host, you can see, for some of these it's taking us 25 to 50 milliseconds. Various stats here about the threads, how many threads we're actually using, how many database connections we're using, and then how many events timed out. So you see this like when the system's under heavy load or something's going really wrong, like if there's a lot of timeout events. But there's just a wealth of information that they've been able to pull out and show. And so with this, the nice thing about this whole thing with Prometheus is you can basically go and you can change this all. Like basically what NHS and InfiniWorks here is provided is just kind of a out of the box pre-configured setup, which works pretty well. But you can go and if you kind of learn how the how to configure this stuff in Grafana, you can build like your own dashboards with different information. So yeah, so that's just basically, that's kind of my demo of the Prometheus and what they've what the community has done around integrating Prometheus with Rancher. Shannon, are you there?
I am. I was muted. Sorry, I was trying to unmute myself. That was awesome, Darren. Thanks so much for sharing all that, and special thanks to Ed Marshall, Jolyon Brown, James Barwell, and the teams out at Infinity Works and NHS that built this. It's incredibly useful. I think one of the things that we're seeing more and more as Rancher is used, in larger production environments and by a lot more organizations is people are trying to understand not just how to manage their workloads, but also how to manage Rancher itself. And I think this is one of the best approaches, I think, for really understanding what's going on your Rancher server and maintaining that health. I mean, there's a lot that goes into running any production service. So this is a great tool. There were a couple questions that came in. So the first question was from Kevin Dwayne, and he asked, what are the hosting requirements for the Prometheus stack when you roll this out?
So what are the hosting requirements for the what?
For the Prometheus stack, like what are the hosting requirements to deploy it?
Oh, right. So I mean, so right now this is I wouldn't say this is like an HA setup or anything. So right now the InfluxDB. So basically, the most of the stuff that's being persisted is going to the Prometheus or InfluxDB, and these are basically just using like the local storage. So if these are deleted, then you lose the data. So this is not really an HA setup. So it's a relatively, it's not a very heavy setup. When you go and you deploy, let's see, a couple of these services will go to every host, but they don't add much overhead kind of to the host of collecting everything. CAdvisor is actually the one that adds the most amount of overhead. But then the services themselves, of like kind of the central services of Prometheus and Influx, are also, don't really, we're really not pushing enough metrics to really kind of be pushing the system. So they don't require much resources. But again, it's not really an HA setup. As Shannon mentioned, we're really looking at, we've had a lot of requests of building in more kind of dashboarding capabilities into Rancher, and we definitely don't want to kind of duplicate what, it's like there's so many great tools out there like Prometheus. So, we're looking at how we can actually just build this more into the product, like probably more of an official catalog entry. And so, at that point, when we, kind of officially support it, it would be a real HA setup. But right now, there's kind of the guarantees of what NHS and Infinity Works have done.
So another question came in from Richard Bucker, and he asked if, it seemed like there was a lot of heat being generated, here. What's the ideal size of a Rancher node once it has been fully instrumented?
Rancher. Oh, well, there's. Are you talking about basically like the control plane, like the Rancher service? Because the nodes themselves, where the containers run, you can run basically as small as you want. You can run like a 512 megabyte droplet on DigitalOcean. You just have to be worried about how big your application is. But for the actual Rancher server side, where our control plane and orchestration stack is running, kind of the minimum deployment is really a 1 gigabyte VM. That's going to basically just kind of get you running. In a more production size, like if you want to do a full-scale HA, really high availability, you can deploy, tens of thousands, if not like 100,000 containers. The larger deployments that we would do would be basically 3 VMs that are 16 gig of memory each. But what we see for most of our users is 4 gigabytes of memory is really plenty. So we've seen, basically one VM with 4 gigabytes of memory. And that ends up being, works quite well for, a size of about like 50 hosts.
Do you know, so thank you. There was another question, 2 questions actually. I'll try to get you to address both of them, and then we're going to move on to the next topic. But one was from Gilman, and he asked, how does this interact across Rancher environments? And the second was from Chris, who said, can you set alarms or notifications for error conditions?
Yeah, and so this doesn't work across environments. So this is just kind of everything in Rancher right now is scoped to an environment. And this is actually one of the the more tricky things we've been trying to figure out as we've been talking about pulling this capability, like, as a first-class thing in the product is basically how do we aggregate up multiple environments into one view. And so that's something we're really still working on, but right now it is per environment the way that's working. And then, shoot, I already forgot the second question. What was the second question?
The second question was about how to, oh gosh, what was the second question? It was how to span across multiple environments, and then the other one was, oh man, now I've already deleted it, so I don't have it in front of me. Of course. Well, I'll remember it in a minute, and I'll ask you. It was about alarms and notifications.
Yeah, I'll come back.
Alarms and notifications. I found it.
Oh yeah, the alarms. Yeah. So that's, basically that's built into as like a Prometheus feature. Let me see if I can get actually to the Prometheus.
I've taken you off presenter though, Darren, so you can set that up in Prometheus.
Basically, there's alerts. Oh.
You're not presenting anymore.
Yeah. So basically, in Prometheus, there's like one of the the Prometheus service. You can go into that and basically set alerts. So when things cross a certain threshold, you can alert to some action.
Awesome. All right, great. Well, we'll just keep us moving. I know we're running out. As always, we're running long. So I wanted to jump into the last of the services Darren's going to go through, and that is Janitor. And Janitor's should be pretty quick. It's a pretty simple concept. It's based on a Docker cleanup software that was written by the team at Meltwater, which is very well done. It basically goes in and identifies Docker images that are no longer in use and removes them from the host, which if you've run Docker for a while, this can be a big issue. And Steve Shipway, who's part of the team at the University of Auckland, actually took this, developed a service for Rancher, added it to the catalog, and it's incredibly useful. I use it all the time myself. So Darren's going to just walk through the Janitor, show you how to set it up, and I think it's definitely one that you're going to want to consider how you deal with this problem, because if you're not careful, you can fill up the disk on your host very quickly with a lot of unused images as you cycle through new versions of containers. So Darren, I'm passing the ball back to you. You should be able to present and jump through it.
Yeah. So this will actually be a super quick demo. Just kind of when someone was asking about alerting, you can see in the Prometheus stack, you can just go and click on 9090 here, and this gives you the kind of the raw Prometheus interface, and you can do whatever you want with Prometheus. Prometheus is actually a very very good monitoring tool. Kind of covers the whole gamut of things you'd want to do. But okay, so let's go and look at Janitor. So Janitor, again, it's just in the catalog. I already have it deployed because I wanted to kind of show historically that it's been doing things. So I'm not actually going to click deploy here, but I'll show you basically the options here. This is if you don't want it to run on a host, then you can add this label to any host of exclude equals true. By default, it will run on every host. Then you can put a comma-separated list of images that you want to keep and a comma-separated list of containers that you want to keep. For this one, you don't need to worry as much because for the most part, unless you're manually running Docker containers on the host, we clean up the containers for you. So the big important one here is the images, which Rancher doesn't do by default. We don't delete the images. And then this also will clean up volumes. So once you go and you deploy this, you can see it goes and it deploys as a global service. So you can see in this environment here, I have 10 hosts. I'm running with 10 hosts on DigitalOcean. So you can see here in this stack for Janitor, you can see it's 10 containers because it's deployed as a global service. So basically one of these is running on each host. And if I just go and I click on any one of these and I show the logs, you can see basically what this has been doing. I've been, as I've been preparing this demo, I've been deploying this service over and over again. I build the cloud high. So I deployed that and then I deleted it, and so it found it that it didn't need this. So you can see it's been doing various cleanups. The interval right now is an hour. You can change what that interval is, but basically this will just sit there and run there and just look for unused things and deletes them. So it helps to keep the disk usage low. Works really well. Okay.
Awesome.
That's it there, Shannon.
Great. Well, thanks, Darren, for doing all those demos today and jumping through a lot of different things. Hopefully this has been helpful and gives you, kind of an idea of how to not just use some of these tools, which are really useful and important as you start to, manage larger scale deployments and containers, but also write your own tools and leverage them. Hopefully we'd love to have more of this type of thing in the future on future meetups. So if you're writing something that you think is relevant and interesting, please, please kind of share it with us. Put it in the, reach out to Darren or I and Twitter or LinkedIn or email, whatever's easiest, and let us know what you're building. We'd love to have more people presenting and speaking on these meetups about projects they're developing, work they're doing, and and some of the cool tools they think would be helpful. Okay, so next up, we're gonna be talking about Vault, and Bill, I'm going to make you the presenter, and you can jump into your slides if you're all set. It looks like you're still muted, so I'm going to just unmute you. Can you hear me okay? It looks like you're still muted. You may need to unmute yourself.
All right.
There you go. Okay, so you should now be the presenter, and hopefully you can share your screen. Perfect.
Cool. Cool. So I'm going to be talking about Vault and just kind of what that is, for those that are not familiar, and also sort of how we're thinking about kind of a first pass integration and using Vault with Rancher, and just kind of the workflow that it sort of looks like now, keeping in mind that it's early, rough, and still, we're getting feedback and working with customers and users to try and get kind of what it needs to look like, and trying to get the experience in something that's nice and workable. So here we've got Vault. It's developed by HashiCorp. They're the team responsible for some really great tools in the DevOps world. We're big fans of Packer and Vagrant and Console, and they've just they do a really good job when they come to a problem space and trying to solve that. So Vault seems to be a market leader. The competition would be something like Kiwiz from Square, but they're really working to build this solution and making it, they're just really pushing it a long way. And so its basic functions are to kind of include secret storage, which is a big problem just in general with computing in large distributed systems, managing key rotation, and then being able to sort of audit and go back and look at where those secrets went, who got them, how they were created, what were they used for, and so that's kind of its wheelhouse. And then we're working on kind of our rough integration, and so it's sort of working, but it is demoable, but it's not fully baked and secure or yet. So we'll be putting something out in the catalog along with the code, so that you can look at it and we can start getting a lot more eyes on it and a lot more feedback as far as the approach and how it's going to get rolled. And so we were working with, we were kind of reviewing this with IBM the other day, and they helped us kind of map out the workflow, and just so we'll share that sort of with you right now. So an admin is going to come in and create what's called a cubbyhole in Vault. It's kind of a really cool concept. Basically what you do is, if you think of it like a locker at a bus terminal, you go in, you put a secret inside, or you put something inside that container, and then you lock it and turn it with the key, and then basically you come back with the key and you unlock it, and then you take what's out, what was in there out, and then basically, that key, you don't get to take it anymore unless you put a new quarter in, and then it's a separate, and for all conversation's sake, it becomes a separate thing. So you would create a cubby hole with a key that has two uses, one to put it in and one to take it out, and a short time to live. And basically you'd want to set that at like an hour or however long it would take an admin to go and deploy the next step. And the secret that you're storing is actually the key that you would be using to issue other tokens for your applications and their secrets. So that the reason the cubby hole to launch the service kind of makes it nice is because you would be passing that temporary token as an environment variable or config parameter through Rancher, and then so anyone that had the access to that environment could then get the key to do things. But in this case, with the temporary token, as long as the service started, that key is now useless, or if it expires, you can't actually get the secret. So the cubby hole thing is really cool, and the solution we're building is based heavily on these cubby hole concepts. All right, so you would create the permanent key and you would put it in your cubby hole and take the temporary key and pass that down to the service. You'd go to Rancher, and sort of what we're recommending is there's this service bridge that will help bridge Rancher events to kind of Vault tokens. And we're planning to make that a catalog entry, and you would provide it with the Vault URL, the cubbyhole identifier, so there's a path in Vault. It's very similar to console with its kind of naming key spaces, and so you give it a path in which to go get that, and then the access token in which you can go and unlock that. And we recommend that that be deployed into kind of its own separate environment from where you actually run your applications. And we also assume Vault already exists outside of Rancher. HashiCorp's kind of the best practice for running that is, I think they still recommend VMs, but basically in a separate area from where your users are actually running stuff. Okay, so once they've deployed that with the credentials, they also get Rancher API credentials. This service, we sort of are thinking that you would want to deploy one per environment. That way, if anything were to be compromised, the scope would be somewhat limited as far as tokens they could get between different environments. And so then that would be deployed and out here. And so this uses, the container would start up, uses the one-time token to fetch a Vault credential from the cubbyhole. And then, so that would bring the server up. And then you would go to your user environment where you would actually be deploying your applications and consuming these secrets. And then you would launch the agents kind of as a global service across all the hosts. And so what this agent will be doing is getting deployed on all the hosts and then listen on the Docker socket for any containers that are starting. So then when it sees a starting event, it will send a request for that event along with the UUID from metadata right now, but we're working on figuring out what the right message is to get that over to the service so that it can then get validated with Rancher. So Rancher is going to be looking at the container, the message that was sent over, and then we're also going to be looking at Rancher's knowledge of that and being able to match several points along with the Vault bridge or agents being launched with Rancher API keys. So that would provide some authentication between the two services. And then once that's validated, if it is validated, The service then goes and looks for policies to associate with that. And then if it finds one, it then creates a temporary token and a new permanent token for that application to use. And it creates the cubby hole for it. And then that message gets passed back down to the agent, and the agent then writes, using a Docker copy, it writes a file into temp-secrets.txt right now with the cubbyhole URL and the cubbyhole path, and then the token which to use to get to open that locker. And then once that happens, that's where Rancher steps out. We've seen some Sidekick containers that you would launch, like there's a Vault Sidekick from the Home Office in the UK that they've used. And so it sort of takes the tokens and then knows it has all of the secret strings that it knows to go look for, what to do with them, and manages renewing them. But it really manages talking to Vault. The problem that this is really addressing is how do you bootstrap those sidekicks, or how do you bootstrap it so that your application knows how to get the tokens to go talk to Vault. And so it's sort of just trying to really, Rancher at this point is just really trying to bootstrap that. And then the secrets are still managed through Vault and that UI, and your containers still need to be somewhat Vault aware, either through a Sidekick or your application. So that's probably a lot to digest. I imagine questions will be coming, so Shannon, as this, do feel free to ask. Yeah, so then the Sidekick then goes and gets its permanent token and starts managing its secrets. So I will try and show.
There's a ton of questions, Bill, that have come in. I think it makes.
Been working on this for a bit, and okay.
I was just saying there's a lot of questions, but I think it'd be better if you just go into the demo because given time and everything else, it'll answer a lot of the questions anyways, just going through the demo.
Okay, cool. Here I've got a Rancher environment. These are the same management server, but I've got a tooling environment where I've actually deployed a Vault dev server, and I've also deployed our listening agent. We don't have the catalog entries for it yet, but you can see it's getting events as I was trying to mess with it and make sure it was working, and hopefully had something to show everyone today. Vault right now is just set up in dev mode, and it's got some secrets stored in there. So just kind of looking at this, I've created a bunch of policies. So I've got a grantor policy, which allows me to create tokens, and it has, the grantor just basically allows me to do that. It doesn't really let me go grab a bunch of secrets, although I think because of the policies that get applied to it. And then I've got policy for app A, which allows me to get secrets from here. And then I've got a policy for app B, which gives me a secrets there. So these two, if you have one of these policies applied, you should not be able to see the other secrets. And sort of right now what we're doing for that is on the secret, on the token that gets created for this, there's a metadata of config path. So I've just chosen /secrets bridge and then gone with the environment name. But then it actually looks more for this. And so it follows, when it goes to apply a policy, it follows rules of specificity. So starting with the path ends up being the environment, the stack, the service, and then the container. And then it starts from the container and searches back looking for policies to apply. And so that's sort of how I'm right now managing the configuration of it. Since Vault is already a key value store, may as well leverage it as part of the solution. So I've applied some of these policies, and I've written a few secrets. Just kind of, I think my username is Bill for test 1. So coming back to this, we can watch, see if we're getting events. Let's watch. So here's 2 hosts. I've already deployed out the secret agents as a global service, so each one is sitting on a host. If I go to my stacks, I've got test 1, and so and it's got an Alpine service, and then we'll just start that up. And then test 2, you can see events are happening over here. I'm searching the path, and looks like I just had a verified object. And then here on test 2, I start that up. And if I go look at my containers, and so what's happening here is these are verified containers with Rancher, and so now they are getting these policies applied to the containers as they're starting. And so I have a limited amount of time now to go and actually jump in and see if we actually got what I expect. So in the temp, I have a secrets text file. And so if I update and get curl, I can now do curl stage x vault token, and just grab this token. Do temp token. Hope that works. And then my cubby hole is cubby half. If everything works, yeah, I got my permanent key here inside this container, and so now I could then do curl minus vault token. Here's secret default test 1. This equals true. And try that again without the white space. Oh, I'm in test 2. Well, okay. Weird. So something went awry, but basically the flow here would be that the policy applied to this token gives me access to
Kyle suggested that you are still using the temporary token, and that's the problem. I don't know if that's...
Did I? Oh. Yeah, so I...
Thanks, Kyle.
Yeah, so the temporary token, you can see the properties of Vault, that it revoked it, and it made it no longer useful, which is what we wanted. All right, well, this shell is a little bit challenging to use. I'm not sure I want to type out the whole thing. But using that, I could be able to, if that was valid, then I'd be able to go get the secrets that were stored in test 2, and then if I went into the other container, I think it's probably expired by now. Yeah, so here I have a whole new cubbyhole and where to go get it and a new token. But I think right now by default I've only set the TTL on the temp token for about 2 minutes, and I think I probably wasted a little bit more time on that trying to get the secrets out of the vault. But basically you would use this, you'd have another little process here that you use to bootstrap something that actually manages your secrets and grabs things from this cubbyhole. So that's kind of what we're thinking right now for a vault integration, just to really enable users to bootstrap their containers with a set of credentials that they can then use to go talk back to Vault and then get the secrets that they need and leverage the full power and capability of Vault itself.
Questions?
That's yeah.
Probably a good one for you know, kind of to start with is let me see here which one I want to start with. So let's start with this one. This is kind of high level. It was asked by Michael Waltz, and he said, is Vault the recommended way to put environment secrets into Rancher environments, or are there other methods?
So there's a lot of tools that are coming into play right now in this space. So Vault is, from what we've seen, appears to be a front runner as far as solutions to manage secrets. Keywiz from Square is another one that's pretty popular, and I think there's other tools. You know, based on the popularity of the tool, you know, we see this as something worth sort of exploring. But the workflow that we're going through with this is basically we're providing a way to verify identity. And so there's nothing that this, I think this could be extended so that if you launched a container, you could have multiple different types of verification and then basically create something to get the secret back into the container once you verify that identity. So we're trying to come up with a fairly generic approach, or at least a pattern that others could follow if they don't decide to use Vault or they wanted to use something else. But in this space right now, it does seem like Vault is kind of the way people are leaning, and so we're
it's definitely one of, yeah, it seems like one of the popular choices that we're seeing out there. There is, you know, I mean, if you're not going to use a full secret management solution, what are some of the other options, Bill, for injecting secrets into containers? So I know people, you know, a lot of people aren't using a full secret management platform.
Yeah, I mean, without this, you've got just kind of your more traditional approaches, but in containers specifically, people have been using environment variables, metadata stores, like either Rancher metadata, etcd, console, with some basic SSL and authentication to those services. You have your more traditional approaches if you've been using Puppet, Chef, Ansible. They've all got solutions that sort of kind of fit in this space as well. So you have a lot of options. These types of tools seem to be the kind of the next generation of things that are really trying to address kind of the onslaught of, or the wave of microservices that are coming.
Great. Another question that came in was about two-factor authentication. Do you know if that is supported? Peter asked if it's possible to integrate some sort of two-factor authentication to Rancher's server login page, like Duo Security. Do you know anything about that and how that would work?
I mean, it's something we could look into. I'm sure that's tied more to Rancher server than kind of this Vault integration piece, but I know there's different solutions out there that offer two-factor auth. And
you can also just do that through your AD or LDAP, can't you? And I know I think people are doing it that way as well. So if their LDAP's authentication uses two-factor, then that would automatically get pulled through, I think, isn't it?
yeah, and then GitHub is roughly the same way. You can have two-factor auth on that. And so as long as that user was authenticated and authorized that application, you have two-factor auth there as well. Yeah, so I mean, yeah, with some of the external providers that we're using, you could probably get pretty close to what you're looking for there.
Another question was from Berger Gudbrigson. I hope I got that right. He asked if he heard correctly when you said that Vault should be run in a virtual machine. Can you reconfirm that and maybe explain why?
Yeah, so at this point, you can run it in a container, but you are containerizing it yourself. I mean, the Vault dev server I'm using is the most popular friend pulls on Docker Hub container of Vault. But right now, what they're sort of saying is they're having trouble coming up with an official image due to the build process and how it would be stored. Given the nature of what people are using Vault for, being able to verify that supply chain of where that software came from and validating that it is where it's supposed to have come from, they recommend that. They do recommend, if you do run it in a container, from what I've read as a best practice though, you shouldn't be running it with a lot of other services, particularly anything that would be user-facing. Again, given the nature of what Vault's being used for, it's kind of the keys to the kingdom, and virtual machines have, full virtual machines have kind of a longer history and track record of providing isolation and security. In containers, that space is still evolving. And just in the raw Docker and without a lot of modifications, I mean, it is possible to break out of containers. So it just hasn't been battle tested yet. And so from what I've read from Vault and their best practices from HashiCorp, they still recommend you'd install it on a virtual machine. Mm-hmm.
Thanks. Two questions that John Engelman asked. The first was, how does the Rancher service declare which policy it wants to acquire in Vault? Is there a mechanism for configuring which services are allowed to acquire which policies? Do you want to address that first, Bill? I'll ask the next one.
Yeah, I sort of showed. Yeah, I sort of showed this, but it's really not very clear. So when the permanent token, so is this legible?
Yes.
Okay. So this just is a quick little script to kind of bootstrap and get a temporary token to start the service. And so when I create the permanent token here I'm giving it this metadata called config path, and it's in the general secret store. And so you would only give read access to this permanent token for this space. You wouldn't give it to any other application or any other key that wasn't going to be managed very, very close. But here, this secrets bridge default is where this service will get its path or configuration data. And so what it's doing is here, this line I wrote in secret bridge default test 1 policies equal default test 1. And what this piece here is that config path, and then this path here is basically follows the environment, the stack name, the service name, and then you could even apply the container name. So you could say, and it's basically, it starts at the most specific one and looks for this policies key. And if it finds it, that's the policy that gets applied. So when the container starts, Rancher knows a lot about it, like where it's running and what its name is, and taking all that information from the Rancher server, not coming from the agent up, it's able to look at that and say, okay, this container is, it belongs to this service, and then it tells this bridge service that, okay, here's this object that, here's this container and here's its properties, and then the service basically just looks and goes and says, okay, in Vault, this is the policy I need to apply to this new token, and creates it and then applies it. So if I do something, I only have a default test 1 and a default test 2. If I create a default Alpine, it will get no secrets applied to it because it will find no policy to write. And then, and since it finds no policy, it just doesn't create any secrets. So you do get that ability to configure which app gets which secret.
Awesome. Last question on Vault, and this is also from John. He was asking if there's potential for integrating the Vault-secret-agent with the Rancher metadata API so that containers do not have to be Vault aware.
Maybe. The rub there is that Rancher metadata is pretty broad in what you have access to. So you can look at the properties of any container, and so there'd have to be something that was done along those lines. But I think
so I was going to say, we have been looking at providing a more secure access, because we control the whole network path and everything, more secure access to Rancher metadata, such that you could rely on it as like a more secure source of information, and then it would be private to the container.
Yeah, and then the trade-off just becomes, like, when you manage secrets in Vault, everything has a lease and a TTL, and even if it's infinite, you're basically, as a consumer of Vault secrets, you're supposed to check back in periodically, renew tokens. If it generates tokens on the fly, like if it's using it to generate Amazon keys on the fly for you, there could be a lease in which those keys get revoked, and then your application needs to know to go get a new one. And so, the UK Home Office has done a really nice job with their Vault Sidekick, and kind of shows a good pattern and provides a lot of flexibility in how to deliver those secrets to your application. I mean, even if you we're talking, if the metadata API was delivering those secrets through Vault, you'd still be having to write your application to understand those concepts, and something. It would be written to something specific. Great.
All right, Bill, that was fantastic. Thank you so much for covering so many things. In covering that. It's a very complex setup, so I realize it's kind of a hard thing to go through quickly. I want to switch now and thank Brandon for being so patient. Obviously, this has gone. We're almost an hour and 40 minutes into our session, and we're just now getting into this. I'm really excited to have him talk about the work that he's been doing with Rancher at Dom and Tom, and again given today's topic, he's going to talk about some of the tools that they use, and some of the projects they've been working on, and just kind of give you some tips and tricks. Brandon has been part of the Rancher community since the beginning of the beta, even his previous role before he joined Dom and Tom. So he's helped us in so many ways make the product better with great suggestions, like so many of you on the call have done. So I'm gonna make Brandon the presenter now, and he's gonna walk through his slides and go through a demo as well. Brandon, I think you should be ready to go. Let me know if you can share your screen.
There we go. Yep, it just turned on. So let me put that on here. So I think that should be on here. Let me get rid of this window here. Cool. I'm Brandon, and I work for Dom and Tom. We're first going to go over more about Dom and Tom here, and then I'll get into who I am, because really the show is really about me. Well, we're a small but really powerful company that does a lot of different software development, a lot of different kinds of apps, a lot of different solutions. But really, we started in 2009, and we run by twin brothers, Don and Tom. Tom is out here with us in the Chicago office, where I'm at currently right now in Tribune Tower in downtown Chicago, and then Dom runs up our New York City office. And our New York City office is a pretty great location, the financial district of Manhattan. Cool place. We work a lot online collaboratively, and it's pretty much, even though we have two separate offices, we really work like one. It's a pretty good work situation. Now, since we opened our LA office, I can go work remote in LA. I definitely plan on doing that. We've grown to now like 50 plus employees. We're still growing and still hiring. Especially in like a DevOps department, which I've been heading up here, and we've got a lot of cool ideas for where we want to take it, which I'll be talking about during the talk here. And it's a quick little run through on all what we do here. Our big motto here is do good, be good, such as do good work and to approach it ethically and kind of really kind of push those values forward and keep the kind of quality that we would expect from the application that we use every day. We would actually replicate that forward for our clients. We cover a lot of different areas as a company, but the cool part about how we function with this is we'll do it a la carte or the whole kit and caboodle, whatever you'd like. So a customer could come to us and say, hey, I need to just host an application. We'll host it. I need to get some good design for an application. Cool, we'll do that. We'll pretty much do anything that you would really like. We're really flexible. A big part of our company is we promote holistic development, where we will pick the best tool for the job, and if we're not really sure how to use the tool, we'll do a quick discovery session and decide if it's a good idea, and if it is, we'll dive in, or if not, we'll kind of shelve it and come back to it later. But we're not a shop that will lock into a specific framework and just only work in that and incur technical debt as the years go on, and we don't try out new things. So, kind of going into me. I started my whole little really big programming career at University of Illinois, Urbana-Champaign in electrical engineering and computer science. I started off really in embedded systems, working diesel engines, programming microcontrollers, and doing all of that in C++, and that was fun, but diesel engines sometimes will take 6 years to develop and may not see the light of day if suddenly emission standards change and then it's just not viable. We'll shut the project. And web browsers, you hit refresh and you can see it, and I can hit a button and deploy it. It's fantastic, way more gratification, way more interesting. So started with that about 8-9 years ago now, and that quickly just accelerated. I got really into it, got into real-time applications. Node.js, people told me wouldn't be a good idea, and hey, it's still working out. And really started getting into DevOps and orchestration. I'm the kind of developer that really likes knowing kind of the whole stack I'm working with in some capacity. I have my strengths I play to, but kind of understanding the whole landscape helps, and DevOps is something I started getting into and really enjoying, especially kind of just thinking about the power of orchestrating different systems. And that's kind of where it came into me learning about Rancher. I was a CTO at a previous startup, a small company that makes charging stations for cell phones, and we were growing up a software platform. And Docker was a really great tool I was using, but I really wasn't sure how to manage it at scale. I started writing a bunch of shell scripts and different node processes because that was just a little easier to kind of do more complex logic with. That was okay. I mean, I'm confident myself as a programmer for sure, but I usually trust people with larger dev teams that have good testing put in place. I feel more comfortable with that for anything. And I won't show you my code because it's probably atrocious. So I started looking at different orchestration systems, control planes and things like that. Mesosphere was something I kind of was reading about. Looked great, but I couldn't really get an idea of if it was going to provide the features I wanted or anything. And I was just getting a beer with some friends at a bar below our building, and I heard two people talking about containers. One guy was saying he loved containers, the other one saying he didn't. I just interjected, weighed in, turned out the container guru there was the head of the Chicago Docker Meetup and mentioned Rancher when I was talking. He said you should give it a shot. It's this kind of new thing. It's really interesting. It seems to bring kind of some different things to the table that other people hadn't considered. That it felt great to use. and really kind of understood its purpose in the landscape when everyone's still kind of figuring out these control planes and orchestration frameworks. And that was it. I kind of loved it and went forward with it. Here at Dom and Tom, we, since we do a lot of hosting for clients, but also a lot of very complex application deployments, it becomes really important for us to really understand what's happening at all points in time. Is health failing on an application, and us being able to rapidly deploy this to different locations. We've also been using Ansible for these sorts of things and writing like really robust playbooks for making sure environments are consistent. But the beauty of having these containers, which can be static and have hashes verified on them, it's so attractive. It's kind of hard to pass up at that point, which we could totally emulate or put together with Ansible scripts. But that would take a lot more engineering time, and hey, there's Docker, and I might be biased because I love Docker. So I wanted to bring up one of our most recent projects that was definitely kind of a success story with using Rancher, among many others, but this one in particular. And this is a website called theenergyproject.com. This client had us build them an application. It's in Rails. The database is MariaDB, and production we have it as a Galera cluster across different availability zones. And we're using Amazon Web Services for this whole thing, so that's handled on an RDS, 3 RDS instances. We have a Redis cache and a Redis queue. We separated those out so there wouldn't be any threading issues if they suddenly got a lot of traffic. Our queue is used for one Sidekick process that's really running to generate PDFs on the system, and the web server that sits in front of everything is OpenResty and Nginx. OpenResty Nginx. A container I kind of threw together and compiled out with some extra special sauce in it. The website is mainly for collecting survey data, among many other things. I'd suggest you kind of take a look at it. It's a fantastic website, and the service they offer is excellent too. And like I was saying, it's survey functionality, and it's a very write-heavy system. Like, we're really constantly accessing the database to commit data to it, to read data, and so on and so forth. What's also another major performance point with this is that the Redis queue handling PDF generation, that's running the WebKit HTML and PDF plugin on a system, and we immediately saw that that could hit a bottleneck if we had a bunch of users simultaneously requesting to have a PDF rendered, and that could just lock up all the threads on our server wherever things were. So we really were concerned about that. And first, the application was designed to handle a couple 100 users simultaneously, and that was within realm for the client. And our client got another client of theirs who had much higher requirements, and they really wanted to use this tool in their company. So much that they said they were going to roll it up to 50,000 users for their first implementation of it. And it was going to be done over 3 days in waves, but there would be situations where users will return and maybe redo a survey. So we really had to consider that we're going to have somewhere between 20,000 and 50,000 users a day accessing the site and interacting with it a lot. So a lot of database writes, a lot of database reads, a lot of different scenarios that we had to consider and encounter. And I had programmed some micro-caching into OpenResty, and I did some more complex logic in Lua than what I would normally do with just standard proxy path caching. So that wouldn't be enough. We knew that we could improve response times and handle things accordingly. However, we definitely would still hit bottlenecks. And the Energy Projects client that approached them with all these users also had very strict InfoSec requirements and other things that had to be met. So we got a nice laundry list to work with them on this, and Energy Projects is a great partner. We love working for them. So they just gave us this big list and asked us to help. So we reviewed our application, we're thinking of infrastructure, and I thought, all right, this is a great situation for us to really roll this out on Rancher and use that accordingly and really kind of bolster our system. This since has occurred and everything went fine, and we gained a lot of knowledge from using this, aside from other knowledge I've gained over time, which is really applicable to our tips and tricks section here that we're going into. So really what we ended up doing here is we set up a Rancher Compose and Docker Compose files to deploy this application to our EC2 instances that we had set up. And in order to save money and really kind of run this effectively, we would have we have 2 EC2 instances set up, but one is shut off, and they're using SSDs to boot up very, very quickly within a few seconds through their API. So what what we ended up doing was we set up a full stack that would run on a server and then have Rancher scheduled to run all of this entire stack on every server that was labeled properly as saying this is the kind of server that should be running this. So at any point in time, if we're thinking, okay, like, you know, traffic has got really high, or if our SNS that we plugged into on Amazon pings off an event and starts up the next server, it'll make sure that all of these containers are running on it, and then we can shut it down. The same thing, and everything just kind of keeps purring along nicely. The IPsec networking was great. Bringing that up to our client's client, they were very happy with it. Our client's client was not familiar with container technology yet. They were not opposed to it. They were very interested in how we would be approaching it. So we had to make sure everything was kind of in line, since they would be very, very closely paying attention to it, as, again, it was something that they weren't super familiar with. When it came to ensuring performance on these servers, we took advantage of Docker's ability to do process stapling. So we made sure that the one, on the server level, since this stack doesn't run in the server, we made sure that the network IRQ for our servers is running on two specific threads, two specific cores, rather, on the CPU on the instance, so that there wouldn't be any contention if we're getting a burst of connections in and we have to negotiate that. We also stapled the workers for OpenResty and the Puma processes running Rails, as well as the two Redis instances. So everything kind of had its own space to play in, and that essentially we could guarantee a certain level of threading performance and kind of cut out any sort of variances that we were going to have, where if there's context switching on the processor, that could cause a lurch in the system that maybe could cascade and cause a lot of latency, a lot of blocking. Another thing that we were using here is OpenResty as our load balancer. So instead of using the Hey proxy image provided by Rancher, which is fantastic, we really wanted to have really close control of HTTP2 pipelining and asset pushing before the client requests it on the browser. It's, you know, just really some awesome features to HTTP2. And all we really did was we set up OpenResty so that the first worker thread will long poll, or it'll just continue polling, rather, the Rancher metadata API to see when certain services start that it should be scheduled to attach to, and then it will update its upstream connections accordingly. It doesn't need to do a SIG hop to actually have it pull a new config. Since it's all in Lua, it's able to just kind of update a Lua table of endpoints it can hit, and it keeps track of how many connections are in each, so we could do a least connection round robin and make sure we're not overloading any one of our Puma processes, or if it's got a lot of threads running on it, so we can kind of keep that separated out and keep performance up as high as possible. That gave us a lot of awesome flexibility, kind of working with OpenResty. And on our back end, we definitely use the load balancer image from Rancher. But this was also an experiment I really wanted to get more into using OpenResty at a deeper level, and it seemed kind of perfect, since Rancher metadata API is a really easy curl away in getting information. So kind of going into some takeaways from this, as well as other experiences I've had with running these server processes or anything, and kind of how Rancher and Docker help solve this. A big part is accessible and aggregated, and current logs. So really kind of collecting logs for anything happening in your system is huge. Sure, you're pretty familiar with kind of SSHing in and, you know, checking out var log and going through any sort of logs in there and searching through them. And sure, that can be fine, but if your server's receiving a lot of traffic, or you're dealing with many servers, it's kind of hard sometimes to catch what's going on. So it's really useful to have some sort of service that you can put everything in. Like, for instance, starting moving things to Papertrail here. This Papertrail allows us to archive things in S3, and is a very simple platform that does its job very well and very clearly. That gives us some good introspection. And our newest thing that we're starting up here is Sentry, setting up a cluster of that and using it. Sentry error reporting is fantastic. There are other people in the market. Raygun is one I've used before, as well as New Relics. But it's attractive that Sentry can run on your own system. Therefore, it's quote-unquote free. Obviously, you have to pay for your own hosting. And if you're doing a lot of traffic through your systems, it can get pretty costly, because you need to make sure you can handle all of the, you know, the deluge of error reports coming in from different platforms, especially if you have a web application getting hit by 50,000 users, and you have one error that's thrown constantly on a page. It'll capture that and tell you that error is happening 300 times a second, but it needs to be able to process that information. Another important thing to do, and this is something that I found out the hard way at a previous job, was load testing while scaling and deploying. We had done a launch of a website, and we found out that there was a bug on one of our pages that was causing, this was a Laravel application, it was causing a lot of errors to throw. It literally had blown up Papertrail. We learned of the error because Papertrail sent us an email about 5 days into the month saying that we already were blowing past our 1 gigabyte limit. So that raised some flags that something was definitely afoot if over a gig of text data was flying through. So we saw that it was an issue, and we quickly fixed our bug. And our workflow was to upload our compiled image to a private repo on the Docker Hub, and once that's on there, then we would do Rancher compose, and based on an environment variable in our terminal, it would update the version number of the image that we want. So when Rancher compose would run, it would really just have the Rancher server start up the new process, start up a new container based on our new version of the image, and do that all accordingly and switch it over. Well, the way the application was built, it's essentially would report too quickly that things were accessible when they weren't. We did put a health check in, but it wasn't considering all variables it should have. So it would start up, Rancher would detect, okay, hey, this application's healthy, flip over to it and kill the previous one. And there was enough traffic hitting the server during this that essentially it hit some contention, and would it switch over properly, and you couldn't scale it up, and then SSH wasn't working because we didn't do the process stapling, so every thread is locked up and the system scheduler couldn't really handle SSH right. So we kind of had to sit there with our hands folded until DigitalOcean could get back to us about just kind of cutting off the connection to the server for us so we can actually handle that accordingly. So that was a quick, hard lesson to learn. Everything was fine in the end. It only took us a couple minutes to get it back up, but we definitely, now I especially use load testing services online to replicate user flows and do it en masse. And while those tests are occurring, I'll be running different Rancher scripts to scale up, scale down, and add new images and see what happens, and make sure that our application is built in a robust enough way to know when services are ready and when they really are ready to accept connections. So Rancher also knows when to properly load balance to it and make sure everything's good. And another thing that I've encountered before is applications that are built with absolutely no scale in mind, such as really inefficient active record queries that are run so frequently that really you should be doing a join on a table, and you're going to get, you're going to do one call, get 100 results versus doing 100 calls and aggregating all that data in Ruby. That's just incredibly inefficient when you're trying to run at scale. So it's a really good idea to consider scalability from the start and not later. If it seems like the scalability steps you're going to need to take are going to incur significant development time, then you have to weigh if it's a good idea. But there are many aspects of making a scalable application in any language that you can consider from the beginning and make sure that your code is accommodating of that, so you don't have to do any sort of open heart surgery to make sure your application can work properly in that situation. That is a huge point to bring up for that, for sure. And when I've handled scalability from the start before, I'll use a oftentimes discouraged method, but I don't care, it works well for me, is doing remote procedure calls through message queues. I've used RabbitMQ quite successfully for that. I enjoy it. I've also used ZeroMQ, but the durability and consistency of RabbitMQ is pretty attractive, and in most situations that's very useful, especially for handling financial transactions. And we really don't want something to crash or have the server crash and have us lose a bunch of backlog transactions that still haven't been processed. It's very important, and RabbitMQ is great at that. And with connecting to RabbitMQ, it's very simple in Rancher to just hit a plus sign or a minus sign on the scale level for any process. And then as soon as that process kicks up, it just connects to the queue and immediately can start ingesting requests and returning. So that made the application very easy to scale up and scale down and not really have to worry about too much service discovery. It was very easy to handle. So that's I would say that's a really big takeaway with any of these, is really thinking and just keeping in the back of your mind, like, if this thing needs to grow, can it? Or am I making a really bad decision right now to save 5 seconds that's going to cost me days in the future when we really do need to scale up? So another big part we're doing is we're transitioning our infrastructure slowly, piece by piece, to using this sort of system. We have a lot of existing infrastructure, a lot of sites we are hosting. So and we're spread out amongst Azure, DigitalOcean, AWS. So you can imagine consolidating all these things and moving around. It's pretty time consuming, and it needs to be a very strategic effort so that we don't cause any problems, and we are still able to function with new clients and current projects we have going on while we are transitioning current ones we've already deployed, or even some legacy ones. The OS that we're currently using is, thankfully, the new LTS release of Ubuntu has come out. So 16.04 is what we've been putting on systems, and Rancher OS is something we've also been experimenting with to try and strip down on what's installed on these servers, since Ubuntu is fantastic, but it has a lot of processes running on it that we really don't need to use, and reducing, one, the amount of memory that's used in the server, two, idle CPU, but three, the less running on the server means potentially less security holes if there's any specific package on Linux that's installed that could have a vulnerability. Like we can very much reduce the size of the attack plane that could be accessed. A huge thing that we're getting out of this, and especially seeing the Prometheus logging on here, is awesome for what we're doing with all of these things, is getting better cost accounting and understanding, like, all right, if clients don't have very strict requirements about there being no other processes running on a machine than what theirs is, and a lot of their legal terminology hasn't been updated to handle container systems yet. They most recently just supported VPSs, so it's baby steps to really accept that. If those requirements don't exist, we can co-locate lots of servers, lots of server processes onto the same machines, and reduce the amount of servers we're running overall. So the maintenance cost for us goes down, and we can pay closer attention to those machines and make sure they're working properly. That also helps us out with easily scaling up to availability zones for high availability. If the client says, hey, we want to really have a highly available application, we're willing to pay for the cost increase for that, we can just have Rancher configured to automatically duplicate those containers among each server that we have running in the different availability zones, so that it's properly distributed and load balanced at whatever level we need it to be. That's an extremely useful part, and it gives us definitely just a lot of internal flexibility, since when we're spending a lot of time on just a lot of clerical things, or really maintaining a bunch of servers or other stuff, that time detracts from our ability to really focus on maybe individual applications or other tasks that could benefit from significantly closer sight and visibility. So getting better cost accounting is a huge part for us, to really know, like, all right, like, these processes cost this much money, and this is how we need to distribute it, and we should be aware of how we built this application, where just because we use this one library, it's effectively costing us another $1 a month in server costs. It's a huge thing for us to know. And since we have better visibility in these servers, we can have a more proactive approach and see that an issue is going to occur and fix it instead of being reactive. So, being able to tell our client, hey, there's going to be a slowdown on your server, but we're remedying it and taking care of it. People are much happier hearing that than them having to come to you and say, hey, what's going on? My process is running slow. And of course, like I mentioned before, we're just doing this piecemeal as we go through until we can really accelerate the process and migrate our whole infrastructure over, because our company is growing very rapidly. It's an exciting time, but that does mean that we have to be very careful with how much bandwidth and work time we're associating with different projects, so we can still move existing infrastructure over onto Rancher while we are building out new. And that's all the information we had to show here. I will be sharing some screenshots and video clips of how we scale up our Sentry cluster and other things on Twitter. And so if you follow me on Twitter, I'll have some links up for that, because they all need to be scrubbed of IP addresses and other things that you can see in the Rancher console due to some strict InfoSec requirements we've recently had to adopt with some of our clients. So apologize for that not being in here right away, but we'll get that up, and you can totally take a look at it. Hit me up with extra questions you might have that you'll only see if you see the video and screenshots.
Awesome, Brandon. Thank you so much for sharing, about your story and the work you've been doing. There was a couple questions that came in. One was from Tim, and he asked, if on these different projects for different customers, if you have, fully independent CI/CD, pipelines for each customer, and then they are connected to Rancher independently, or if you're sort of managing it each environment is its own. Each customer has their own environment. So can you maybe sort of talk about that a little bit?
Oh, yeah, absolutely. So in the situation where we're really co-locating onto the same server, let's say a bunch of small landing pages and WordPress sites, where really even having a $5 or $10 VPS instance running one of those is more expensive than it would be to have it just kind of all running at one machine. We separate those out into stacks, and we make sure those stacks are just isolated, and we do proper API key accounting so that we don't accidentally push data to a stack that shouldn't go there in some deploy process. We're very careful about that. Now, when it comes to the clients that have more strict requirements where they need to be on separate machines, we will create isolated environments that we will use then through the just through the standard Rancher console. We will just click between environments and kind of handle things accordingly. On top of that, though, when it comes to deploying to these environments, we obviously have the staging environment and dev environment we use just so we can throw a bunch of different common servers and processes on there to get developers going. Those are allowed to be pushed to by the current developers on a project, but our production ones will only be allowed to be pushed to by tech leads, department heads, and DevOps employees, just to reduce the oops scenario where you happen to somehow have an API endpoint that you didn't switch over in some file, and you end up pushing beta code to production and everything comes down. We're trying to cut down as many of those possibilities that could occur.
Got it. Great. And the other question that came in was about Compose. Are you using Compose for most of these environments and deploying from, or are you sort of and upgrading through sort of the Compose lifecycle? How are you upgrading and deploying these more complex stacks that you're describing?
So for the energy project, like I described, we are actually using Compose to do that. And we don't have anything really put in there yet to handle scenarios like, let's say we have to do migrations on a database. That's always kind of a hairy process to go into, because sure, we could do a deploy of our, let's say only our Rails image updated. So we do that deploy, we restarted Puma, we find out that it doesn't work, we can roll it back. That's cool. If you have a production database and you run a migration on it and it fails, you're kind of stuck, and it's not easy to go back unless you make the database write-only, take a snapshot of it, you do this migration, it fails, and you stop the database, restore the snapshot, and start it back up. No matter what, it's kind of a sticky scenario, kind of difficult to handle. So we don't have that accounted for when we do our deploys. If we need to do that, we have a container that will start up, and it has a script written in it to run the migration command at Rails and do all that. But we manually trigger that if that's the case. But we really don't do database migrations or anything like that after we've hit production. We avoid it at all costs because of how difficult it is. So yes, we can just run that straight through Compose. Just run a Compose update, or have it just wipe everything out and start over, depending on how we want to approach it. We have it do that. We have it start the processes up first, and once all the processes are started, then the load balancer flips over, instead of doing a rollout where some of the processes may be using old code and some may be using new code. That can cause problems that are with updates to models and databases if that ever occurs. So we just have it start everything up first and then flip.
Great. Awesome, Brandon. And was there anything else you were going to show, or I think that was the last of the questions that have come in. I can certainly, if any more come in the next few minutes, if you stick around, we can definitely pull them up and go through them in a bit. But anything else, or is that about it? That's
about it. Yeah. Okay. So I'll be sticking around. So any question that comes through, sure, shoot them my way.
Awesome. Well, thanks so much, Brandon. And yeah, sorry we couldn't get the demo stuff approved through the IPsec stuff. But thanks for posting all that to Twitter and sharing the videos. I think that'll be great for everyone to see. Just make sure you hashtag it with Rancher Meetup, and we'll get it out there to everyone as well. All right. Well, we're now well over 2 hours, so I want to kind of wrap up and kind of hit the last couple things we just wanted to discuss today before we finish up. Let's see, hopefully I'm presenting. Darren, are you still there?
Yep, I'm still here.
Okay, great. So why don't you just announce just a couple quick things about upcoming releases. Do you want to go over these real fast, Darren?
Sure, yeah. Yeah, so in last month, kind of our major thing was that we released the 1.0 and 1.01. And so just kind of letting people know how the versioning will work going forward is the 1.0 is our kind of stable supported version. And then we will continue going forward with our kind of our weekly, bi-weekly cadence of pushing out new releases and builds, but that will be done under the 1.1. So there's 1.1 dev 1, then dev 2, dev 3, and we'll just keep putting those out until we get to the RC level, which is, would be a couple weeks before we decide to cut 1.1, and then that will become our new stable version. So anyway, so coming out, this week or early next week, we'll be pushing out the first of the 1.1 series, which has the experimental Mesos support, which is very similar to our Kubernetes and Swarm support, which is you can have an environment which is for Mesos, and then you can basically use catalog entries to deploy Mesos frameworks, and we've got a bunch of Mesos frameworks already put in there. The popular ones like Aurora and Marathon and whatnot. I mean, the popular Mesos ones. We're doing F5 load balancer integration. This has come a lot from kind of our enterprise users who are running this in their own data centers. They have their own load balancers. So the F5 design, the integration is very similar to our external DNS. We have a very simple provider interface that you can implement, and we really hope to see a lot of contributions to that project once we put it out. It follows the same design as our external DNS. We're calling this our external load balancer.
Can you talk about
and then the
how
last thing was
that's
that
going to work a
you
little
can
bit?
now customize.
Darren, on that, can you just explain a little bit about what the F5 load balancer integration would involve and how it's going to work?
Right. Yeah. Yeah. And we're still, we're still. So we're pushing out the F5, and then we're still kind of working out how the model works with ELB and other ones, because honestly, setting up a load balancer is a little more complicated than DNS. But the way that F5 works right now is you create a service, and that service has to expose a public port on the host. And then you put a label on the service of what is the target, I get the right term here. Shoot, what is it? I think it's like the virtual server. So basically, it's kind of a pre-configured thing you already have, yeah, it's a virtual server name on the F5. So you put a label which refers to the virtual server name on the F5, and then we'll go and basically set up the pool with the hosts and the pool that has the host IP and port combinations, and add that to the virtual server. And so basically, we manage that pool as that service scales up, or gets deployed to different hosts. And so that's how the F5 is working. And then we're looking at ELB right now, because that'll obviously be a really popular one, on how to integrate with ELB, will most likely be referring to a specific autoscale, not autoscale, it's an actual ID of an ELB. But it'll be a similar approach of putting a label on a service, and then that service needs to expose the public port.
Awesome. Do you want to hit the last one?
Yeah, the last one was in our 1.0 release. We had you can dynamically configure what Docker machine drivers. So if you have a third-party Docker machine driver, you can just configure it. But it would get kind of our default UI, which is not that fancy. And so in the 1.1, we're making the UI configurable too, such that you can provide it's like a Ember component or something. Unfortunately, I'm not really a front-end guy, so it's all of our UIs in Ember, and so there's basically some pluggable mechanism where you can just provide a URL, so like some JavaScript and whatnot, and you can plug right into our UI. Yep.
Awesome. Thanks.
Those are
jumping.
coming out.
Thanks for jumping through those. Also, the 1.01 that we talked about last month is now available.
Nope.
with that, the multi-node configuration and deployment of Rancher as sort of an HA cluster is available. So if you're trying that out and running into anything, please file bugs and let us know if you're hitting issues. Otherwise, it should be I know a lot of people have already got it set up and running, so hopefully it's working well for people. The last couple of things, just really quickly, if you're not aware of it already, to get started with Rancher or Rancher OS, the easiest way is to just download from GitHub. You can go to either project and download directly, and they both are really easy to get started with. You can also find out more at rancher.com. If you love Rancher, share it with people and kind of file issues, get involved, help us make it better. There's a ebook on continuous integration that you can find on our homepage, really helping a lot of people just kind of look at some of the basic form factors for deploying out build processes and pushing through CI. There's a handful of questions left, so I want to have a couple of minutes to answer those, but I realize we're well over time, so hopefully we'll get to everyone's questions. If we don't, we'll follow up with you on email. But one of there were a couple questions that we didn't get to answer about Cowbell and Prometheus and Janitor. So the first question was from Fabian. He was asking if it was possible to use Cowbell behind a reverse proxy connected to a auth service using reverse authentication to secure it. Fabian, I hope I got that right. Darren, do you want to take a hack at that?
Yeah, I mean, I think such a thing would be possible. So, I mean, basically all it needs is a post to a URL. So there's really nothing fancy about in terms of like host headers or anything like that. So running through a reverse proxy should be fine. But the kind of the thing, it's like if it's authenticated, is when you integrate with something like Docker Hub, the whole idea is that they assume they can just hit that URL with no credentials or whatnot. So if it's actually like a secure reverse proxy, it's going to impact what's the use case of where you can use that to actually invoke it. But maybe it'll work with whatever whatever it is you're trying to use it for.
Great. Another question that came up as we were talking about Cowbell, I think it's a good question. Fred, when asked it more than an hour ago, Fred, so thanks for being patient. And he was asking, he says, as far as you can tell, you can't create a container from an unpublished local Git repo containing a Docker file. And he said, it feels like what Rancher's lacking is a Git intake interface like Heroku or IBM Bluemix or other paths would have. Is there any plan to add that feature? Anything you can talk about there, Darren, in terms of how that might work?
I think my connection might be like cutting out a little bit because I lost the one part of the missing what in terms of the Git integration?
Yeah, he was saying it lacks sort of a Git intake interface like Heroku or IBM Bluemix would have. So you can't create a container from an unpublished local Git repo.
Right, yeah, and so that's really that PaaS experience of Git deployments. Yeah, I mean something you would see in a PaaS like Heroku. I think something that like that is definitely going to kind of will come. Kind of from our perspective, we've kind of viewed PaaS as like kind of the next layer above Rancher. So we haven't actually done Git integration like push to deploy, but what we're starting to see is we're getting closer and closer to that. It seems somewhat natural that we're going to end up adding it, but it would most likely not be in the same way as you'd have like Heroku, because we never had an intention of necessarily doing like Heroku build packs and whatnot, but we could probably provide some mechanism that would allow people to do that themselves if they wanted to. So, I think it will come, but it's I wouldn't say it's like necessarily like directly on the roadmap right now.
Another question, this one from Jose Ortiz. He was asking about Janitor, and he wanted to know if you could remove images from a private registry as well as from the hosts. I don't think that's possible, but I figured I'd let you talk to it.
No, yeah, it's just basically focused on the local host, so it won't actually remove anything out from the registry. In fact, deleting things from registries is really quite difficult in general. It all depends on the registry implementation, and yeah, not so easy.
Great. There's another question from Leonard Schweitzer, and he asked about, he's saying, with Cowbell, we now have incoming webhooks. Is there something like outgoing webhooks in the pipeline? Something, for his example was posting to Slack when a service switches to a degraded state, for instance. Anything like that you've got in the plans, Darren?
Yeah, we would love to build basically whatever the reverse of Cowbell would be. We could come up with some clever name for it, but basically you can follow the same pattern of deploying a microservice. So we have a WebSocket-based event stream that comes out of Rancher, and so as things change in Rancher, it's somewhat of a fire hose, to be honest, but if you know what you're looking for, you can kind of filter it down. But as things change in Rancher, we can call out to webhooks. And so I think it would make sense that we could build, kind of the opposite pattern of Cowbell. So I kind of would encourage maybe someone from the community to try that out. But if not, you'll see it coming because the webhooks is constantly requested. So we'll probably end up building something there.
Okay, great. Looks like 3 more questions. So one was from Omid Nitaji, and he asked if it was possible or how to pass HTTPS to the backend server by using the Rancher load balancer. I don't know if you want to share. I can make you the presenter, Darren, if you want to kind of answer that visually. Do you want me to say it one more time?
Yeah, say the question one more time.
The question was how to pass HTTPS to the backend server by using the Rancher load balancer. So how to turn on HTTPS and manage your keys on the load balancer.
Oh, okay. So basically, okay. So basically, like if you're going and you're adding a load balancer here, so I'll show you. You have various different options here in terms of. Oops, stuck. Let's say I'm load balancing port 443. So what you can do is if you do not want to terminate SSL, if you want to do SSL, if you want to actually manage SSL yourself, then basically what you would be doing is you'd be setting up a TCP load balancer, which would just do 443 to the target service of 443. So that's not terminating SSL. If you do want to terminate SSL, then basically what you're going to do is, depending on what the protocol is, HTTP is often, everyone's doing, you would click the SSL here, and then that gives you the option in the UI to choose a certificate. I don't have any certificates uploaded in this environment, but if I did, I could choose a certificate, and you can also have multiple certificates because we support SNI. So basically, if you say you want SSL, that means we're going to terminate the SSL. So you would most likely have a configuration like this, where it's 443, you're listening on HTTPS, we terminate the SSL, and then the connection to the backend is then going to be not SSL. So, I mean, that basically gives you kind of the two situations with SSL if you want to terminate it or if you wanted to go through to the service and manage it yourself.
Do you want to also show where you upload those certificates just to kind of make it clear?
Oh, sure, yeah. If you go into infrastructure, there's certificates here. So you can just go and add a certificate, and there's, let me close this, it's blocking the screen. Okay, and there's basically 3 parts. We need the private key, the certificate, and the cert chain. And these are usually provided by whoever you're getting the certificate from. They'll give you those 3 artifacts, and you just need to post them in there.
Great, thank you. Okay, there was a question from Victor Cortez. He asked, and he asked this a while ago as well, but he said, is it possible for Rancher to deploy an HA container with a different IP than the host.
HA container with a different IP. I mean, so basically every container that we deploy has its own IP that runs like on our private network, not on the host. So I'm not quite sure if that answers the question. I mean, so basically every container does have its own IP, and then you have to, if you want to basically use a port from the host, you publish out a port from that container to the host, and then that port will be available on the host IP.
There was Ed Marshall responded to that same question with a comment. He's saying that they use, they do this and they use Keep Alive D to map external IPs to the services. So that's maybe one other approach to doing it.
Oh. Yeah, I mean, I wouldn't know. Yeah, we're kind of curious to hear how Ed do. I mean, if you're using Keep Alive D, I assume that's basically you're doing kind of like a VRRP type, where you're binding the IPs to the service. Yeah, I don't know. I don't think I know the.
So two more questions. Yeah, two more questions on the certificates and the SSL termination. One was from Lori Kepford, and she asked if the load balancer certificates would work with wildcard certificates. And then Tony Choitz asked if there were any major drawbacks of using self-signed certificates. Do you want to just maybe address both of those?
Shoot, I missed the first question.
The first was, would it work with wildcard certificates?
Sorry, can you say the first question again?
Yeah, would it work with wildcard certificates?
Yes, it does work with wildcard certificates. Yeah. So our load balancer and SSL, everything works fine with wildcard certificates. Usually that's actually kind of their preferred because of the hostname path-based, like the hostname-based routing we do. If you use a wildcard certificate, then you have the ability to change, basically the first part of the domain to route to different services, and so that's really common. The downside of self-signed certificates is always just the fact that every client that wants to talk to it has to trust the self-signed certificate. So it works, self-signed certificates work just fine in Rancher. It just comes with that, regular caveat.
Okay, last question, unless someone sneaks one in at the end. Juan Donoso asked if it was possible to use the Vault integration from outside Rancher, say an app running in Heroku or anywhere else. Bill wants to try.
I don't know if we might have lost Bill at this point.
No, I'm here.
Okay, yeah.
Yeah, to use the Vault integration outside. So the way it's currently being written and built is it relies on Rancher to provide validation that is it. When the code is published, it has the concept of a verifier. And so if you wrote a verifier that sort of, could verify it or just always return true, it could then talk to Vault and inject it through that. But you would need access to the Docker socket, and I'm not sure if Heroku would do that. Because it is overall focused at the Docker container level.
Okay, great. There was one more. Lori got one more question in. Lori asked if it was possible, how she could manage containers so that two containers that both need the same port do not try to launch on the same host. Do you want to talk about port conflicts a bit, Darren, maybe?
I mean, that's so that's just a kind of a default scheduling constraint that gets placed as soon as you publish a port to the host. Basically it grabs that port, and so when we schedule the next container, we have to make sure that port's available. So basically, this is actually a really common problem people run into is that, let's say I have two hosts and then I deploy 3 different services that all want to use port 80. One of them is going to fail because, we can't find it open. So that's a built-in scheduling constraint that we already do. We just look at what ports are being used on the host.
Awesome. All right. Well, thank you everyone for all of your questions, for your attentiveness. I'm always amazed at how many people are still here 2.5 hours later. This was really great. If you didn't get your question answered for any reason, we'll try to answer it via email, or feel free to shoot it to us on Twitter, or always post things to our forums. We are always in there checking. But otherwise, I want to take a special moment to thank Brandon Papworth from Don and Tom for sharing his use case, Bill for doing such a good job explaining Vault and showing how to use it, and Darren, as always, for demoing pretty much anything and everything that that people may want to use Rancher for. So thanks everyone for attending. Thank you all for presenting, and next month we'll be having our meetup looking at kind of using Rancher on the laptop and looking at how to deploy local dev environments using Rancher and catalog items. So it should be a fun, interesting topic as well next month. And we'll be sending out, sign up information for that with the recording from this event later today or early tomorrow. So thank you, everyone. Thanks for all the time, and have a great evening, afternoon, wherever you are. Thanks, everyone.